Welcome to the debate. You know, usually when we walk down the street, we cast a shadow. It is just a projection, right? A totally harmless artifact of light and geometry.
Right, just a trick of the light.
Exactly. But imagine for a second if that shadow started walking ahead of you.
Oh, wow. Okay.
Yeah, imagine if it started opening certain doors while locking others, like whispering to people you are about to meet and essentially telling the world exactly who you are before you even get a chance to open your mouth.
That is a pretty unsettling image, to be honest.
It really is. But that is the invisible machinery of artificial intelligence profiling. Today, we are exploring how AI ingests our digital traces to categorize us and, predict our behavior.
And it is a massive, massive shift in how society operates.
Huge. So, the central question we have to grapple with is this. Does the technical efficiency and incredible predictive power of AI profiling justify its deployment? Or do its social impacts, specifically the way historical data actively replicates and amplifies social prejudices, fundamentally undermine its utility?
That is the big question.
Right. And I am approaching this primarily through an engineering lens, focusing on technical efficiency. From this perspective, AI profiling is really a triumph of statistical pattern finding. It is a workflow where massive data ingestion and machine learning can be mathematically optimized to improve personalization.
Right, the efficiency angle.
Exactly. And I argue that historical flaws in the data can be systematically mitigated through rigorous technical design.
Well, and I am looking at this through a sociological lens. So focusing heavily on those social impacts. I would argue that this process, no matter how mathematically sophisticated it appears on paper, is never actually neutral.
Never neutral?
No, not at all. Because when AI optimizes for efficiency using historical data, it inherently reproduces structural inequalities. It is not just, passively observing us. It is actively shaping human opportunities, altering human identity, and doing so in profoundly harmful ways.
Okay, let's start by looking at the sheer scale of the problem these systems are trying to solve, because I think that context is crucial for the engineering side.
Sure.
From a systems design standpoint, we are dealing with billions of human beings generating endless streams of chaotic, unstructured data, like every single second.
Yeah, it is a staggering amount of noise.
Exactly, it is noise. By combining enormous data collection with statistical pattern finding, these profiling systems do something genuinely remarkable. They reconcile incredibly noisy signals. Think about your own behavior online. A declared interest on a profile might just be aspirational, right?
Right, like saying you love documentaries when you only watch sitcoms.
Exactly. Or, a click might be a total accident because the button moved. A long dwell time on a web page might mean you are deeply engaged, or it might just mean you got up to answer the doorbell and walked away from your keyboard.
Right, the machine does not know you left the room.
Right. So the AI pipeline takes these chaotic human traces and transforms them into what we call actionable numerical features. Through supervised models, which map these features to known outcomes, and unsupervised methods that discover latent clusters of similar users, these probabilistic models maximize efficiency. They seamlessly connect users to relevant content and drastically reduce friction in everything from commercial shopping to, functional decision-making. Now, I won't pretend historical biases do not exist in the data. They absolutely do.
They are everywhere in the data.
But to an engineer, those are essentially data flaws. They are measurement errors. And errors can be rigorously addressed through technical solutions.
I hear the elegance in that explanation. I really do. But the consequences of this technical workflow are fundamentally psychological and social. They are not just mathematical.
How so?
Well, you describe a system optimizing for efficiency, and that sounds great until you ask, what exactly is it optimizing on? It relies on historical data, and historical data is not just an objective ledger of facts,
It is a record of past actions.
It is a literal record of structural inequality. When an AI system optimizes for efficiency using that specific data, it does not just read the past. It risks dragging that past right into the present. It reproduces and amplifies that inequality into the future.
But it is just trying to find the most efficient path.
But profiling isn't merely a technical convenience or a friction reducer to get you a better movie recommendation. It is a deeply social function. It categorizes human beings, it alters their self-concept through labeling effects, and it distributes life-altering opportunities like housing, jobs, and credit based on past prejudices that have been hard-coded into the data.
I see why you think that, but let me give you a different perspective on how that data is actually handled. To really understand this divergence between our views, I think we need to look at the very first step in the pipeline: the translation of human traces into normative features.
Okay, feature engineering.
Right. Before a model can predict anything, it has to ingest data and figure out what matters. It looks at explicit inputs like your declared age, behavioral data like your purchase history, social signals, and contextual data like the device you were using.
Or what time of day it is. Yeah.
Exactly. The technical elegance here is feature engineering. The system assigns precise mathematical weights to these inputs to extract higher-order patterns. It literally takes the messiness of human life and turns it into a structured vector, a row of numbers that a machine learning model can actually process. It is a masterclass in extracting signal from noise.
But feature engineering is exactly where technical choices secretly encode human assumptions. You call it extracting signal from noise, but someone, or some algorithm programmed by someone, has to decide what counts as signal and what counts as noise.
Well, they use statistical correlation for that.
But deciding which behaviors matter, how to aggregate a user session, or whether to prioritize the recency of an action over the frequency of an action, those are not objective laws of physics. They are choices.
They are design choices, yes.
Right, and those choices determine what a profile privileges and what it completely silences. You are taking qualitative, complex human behavior and forcing it into a quantitative box. And that box is usually based entirely on the platform's commercial priorities.
I completely understand why it feels reductive. But aren't we romanticizing human judgment a bit here? Assigning likelihoods and probabilities within these models is an objective, mathematical process. It is far more consistent and far less arbitrary than human judgment.
Consistent does not mean...
Let me just say, a human loan officer or a human hiring manager might just be having a terrible day. They might harbor subconscious biases that are completely untraceable and unprovable.
That is true. Humans are flawed.
Right. A machine learning model, by contrast, relies on a strict probabilistic framework. It assigns statistical likelihoods rather than absolute certainties. It looks at millions of profiles simultaneously and finds correlations that no human mind could ever process. And it applies the exact same mathematical standards across the board. The math doesn't have a bad day.
Consistent does not mean objective, though. Assistant can be consistently wrong or consistently discriminatory. And treating these probabilistic estimates as objective facts is incredibly dangerous.
Dangerous in what way?
Let's look at the psychology of this, specifically the labeling effect from social psychology. If a teacher tells a student they are a quote-unquote natural at math, that student embraces risks, they study harder, they perform better.
Right, a positive feedback loop.
Exactly. If the student is told they are not a math person, their performance drops to match the label. Algorithmic labels operate in the exact same way, but at a massive scale and with total opacity.
But users do not see the labels.
When a system categorizes someone as a high-risk borrower or a low-value customer, those are not just invisible rows in a database. They dictate the actual options presented to that person.
Wait, let me make sure I am fully grasping your point here. Are you saying that by merely tagging someone with a mathematical probability like low-value customer, the algorithm actually creates a self-fulfilling prophecy?
Yes, absolutely.
Because the user doesn't usually see that label. So how does it alter their behavior if they don't know the label exists?
Because they experience the consequences of the label. If you are tagged as a low-value customer, you get routed to the worst customer service tier. You wait on hold for an hour.
Okay, that is fair.
You get frustrated, you interact less with the platform, you spend less money. You become the low-value customer the algorithm predicted you were. Users rarely see the internal logic, but they absolutely accept the algorithmic portraits presented to them.
Like the ads or job recommendations?
Yes, the ads they see, the jobs they are shown, the interest rates they are offered, they view those as authoritative reflections of their worth. They internalize these constraints and adapt their actions. The system doesn't just predict behavior, it actively alters it to fit its own prediction.
Okay, that brings us directly to the core tension regarding historical data and bias. You argue these systems inherently amplify prejudice. But let's take a step back. Isn't the AI just a highly sophisticated mirror?
A mirror?
Yeah, it is held up to society and it reflects the historical record. If our historical record contains deep inequalities, which obviously it does, the mirror is going to reflect them. But we can't blame the mirror for an ugly reflection.
I think the mirror analogy is.
Let me just finish the thought. It simply reflects the empirical reality of the data it is fed. And here is where the engineering perspective actually offers a tangible solution. We do not just leave the mirror as is. Through value-sensitive design, engineers can mathematically polish out these historical distortions. For example, we use adversarial testing.
How does that actually work in practice, though?
Think of adversarial testing like a fire drill for the algorithm. Before a model goes live, we actively try to trick the system. We feed it fake data, we flip the genders or the racial markers of the profiles, and we see if the system makes discriminatory choices.
Okay.
If it does, the engineers can mathematically adjust the weights within the model so that it stops penalizing underrepresented groups. We can find the bias and fix the reflection.
I'm sorry, but I just don't buy that. And let me tell you why. I have to push back strongly on the mirror analogy. It fails because a mirror just passively hangs on the wall. It doesn't do anything. These models open and close actual doors. They actively shape the future.
While they guide decisions, yes.
Let's look at predictive hiring tools as a concrete example. If a tool learns from past successful applicants, and a particular tech company historically hired mostly men from a specific socioeconomic background, the model learns that those exact demographic traits correlate with success.
Right. That is the historical bias we talked about.
Right. It then filters out diverse candidates, systematically perpetuating demographic homogeneity.
But again, if we remove gender or race from the data set entirely, the algorithm doesn't know who is who. It is just looking for skills.
But that is exactly the problem with opaque systems. Bias sneaks in through proxy variables. The algorithm does not need a column labeled race or class to discriminate. It looks at the zip code you live in.
Ah, proxies. Yeah.
It looks at your shopping habits. It looks at the distance between your high school and the city center. It finds these proxy variables and correlates them with its definition of success or risk.
Which were shaped by historical inequalities.
Exactly. Consider credit scoring models that penalize marginalized communities because they have less formal financial history. Maybe they rely on cash businesses or community lending. They're perfectly creditworthy, but they don't fit the historical template of a good borrower.
Right.
And because these probabilistic estimates are treated as hard, unyielding facts by the institutions using them, it creates an inescapable feedback loop. The AI literally helps write the profiles it claims to just read. It locks people out of opportunities, which then generates new historical data proving they didn't succeed, which then feeds right back into the model to justify denying the next person.
I'm not convinced by that line of reasoning because that perspective assumes the model is a static snapshot frozen in time, and that fundamentally ignores the temporal dynamics of modern AI systems. Models are not built once and locked in a vault, They are constantly being updated.
They are updated, yes, but how fast and for whose benefit? Profiles frequently lag behind current realities. People change, they pay off debts, they migrate between cultures, they change careers.
Sure, human lives are dynamic.
But because models are trained on historical snapshots, you get these severe, deeply impactful mismatches. Take a relatable scenario. Someone who was struggling financially for years finally gets a great job and pays off all their debt. But the algorithm's decay rate, the speed at which it forgets past behavior, is slow.
Okay, I see where you're going.
So for the next 6 months, this person's still aggressively targeted by predatory payday loan algorithms, simply because the model hasn't caught up to their new reality.
But the decay rate is exactly the kind of technical lever I am talking about. Engineers constantly tune these parameters to fix that exact problem. Deciding how fast older data mathematically fades into the background is a feature, not a bug.
But they often don't tune it fast enough for the consumer's benefit.
But it allows people to move beyond their past patterns. The system is designed to catch up. And regarding the lag, the continuous retraining of models and hyper-targeting actually inherently solve this. Modern systems constantly ingest real-time scoring of user intent.
Real-time scoring, right?
Yeah. When you get a targeted ad that references a search you made 10 minutes ago, that uncanny resonance provides immense convenience. It anticipates your needs almost instantly. The entire engineering goal here is to reduce friction in communication and commerce, and microsegmentation achieves that beautifully.
That's a compelling argument. But have you considered the cost? It achieves commercial efficiency beautifully, yes. But does that convenience justify the immense surveillance and behavioral shaping required to produce it?
Most users seem to prefer the convenience.
Yes, an ad that perfectly anticipates your need feels incredibly convenient in the moment. But it also reveals the terrifying breadth of inferences being drawn about your most private thoughts. It fundamentally erodes perceived privacy. The commercial logic driving this profiling prizes fine-grained segmentation strictly because it reduces friction in persuasion. It monetizes human attention.
Well, it is an advertising model.
Right. And when you talk about decay rates as an engineering triumph, you are actually making my point for me.
How so? Tuning a decay rate is a purely mathematical adjustment.
Because deciding how long a past behavior should influence a person's present is a profound normative judgment. It is not just math. If someone defaults on a loan or looks up a controversial political topic, who gets to decide how long that shadows them? 6 months? 5 years? Forever?
I mean, that is a valid question.
That is an ethical and social decision masquerading as a technical parameter. Furthermore, look at cross-cultural mismatches. We have global platforms deploying models trained predominantly in one region, say North America, and applying them to completely diverse cultural contexts. Features that mean one thing in one culture signal something entirely different elsewhere.
You mean like computer vision models reading facial expressions?
Exactly. Imagine an automated video interview system trained on American norms of extroversion and constant smiling.
Right, we smile a lot.
We do. It analyzes a candidate from a culture where a respectful, neutral expression is the professional standard. The algorithm misinterprets that cultural norm as disengaged or lacking enthusiasm and flags the candidate as a poor fit. These models can severely misinterpret foreign users, misrepresenting identity, or worse, pathologizing culturally normative behavior simply because it doesn't fit the training data's baseline.
I completely agree that cross-cultural deployment is a massive challenge. I really do. But from the engineering side, the answer to these issues isn't to abandon the technology. The answer is transparency, explainability, and rigorous structural safeguards.
Safeguards like what?
We can give users actionable disclosures. For high-stakes contexts, like those automated interviews or loan approvals, we are increasingly mandating human-in-the-loop systems. That is where a machine makes a recommendation, but a human makes the final call. We are also implementing differential privacy at the data ingestion level.
Let's unpack that for a moment, because differential privacy is a term that gets thrown around a lot as a silver bullet.
It is not a silver bullet, but it is incredibly powerful. Imagine taking a highly detailed photograph of a crowd and mathematically slightly blurring every single face.
Okay, so you lose the individuals.
Right, you can still tell it is a crowd. You can still see the general movement and flow of the people, which gives the algorithm that macro patterns it needs to work. But you cannot identify any individual person. By injecting this mathematical noise into the dataset, differential privacy protects individual identities while preserving the overarching statistical trends.
I see.
If a user can see a meaningful disclosure about what data sources were used, understand the decision context, and access a dispute channel to correct profile errors, it restores their agency. We maintain the massive efficiency of the system while mitigating the harms through ethical design.
Transparency is vital. I won't argue against that. But explanations and disclosures are not simple cures. First of all, the explanations provided to users are almost always shaped by the platform's priorities.
In what way?
They choose which features they highlight in the disclosure and what causal story they want to present. They might say you were denied because of your credit history length, while hiding the fact that the proxy variable for your zip code was the real deciding factor.
That is a fair critique of how explanations are delivered.
Secondly, if you make these systems completely transparent, they get gamed.
Gained by the users?
Precisely. Users with high digital literacy, often those who already have societal advantages, will figure out how the algorithm works and alter their behavior specifically to optimize desirable labels.
Right, like search engine optimization for your life.
Exactly. They will know exactly what keywords to put in their resume or how to structure their online behavior to look like a high-value citizen. This leaves less savvy users, who are often already marginalized, to bear the absolute brunt of the algorithmic penalties.
I hadn't thought about the literacy gap in that way.
Or alternatively, the transparency just overwhelms people. A 30-page technical document explaining the weights of a neural network does not translate into meaningful control over your digital life. This is why we need robust algorithmic accountability frameworks and actual independent impact assessments for high-risk systems.
So you are leaning toward structural regulation.
Yes, we need societal conversations supported by regulation about which inferences are entirely off limits. Relying solely on technical workarounds places the burden of protection entirely on the individual rather than the systems extracting value from them.
I think it is time we summarize where we stand today. From the engineering perspective, AI profiling translates messy, chaotic human lives into structured, actionable signals. Yes, historical data contains deep biases, and yes, deciding how to weight features involves assumptions. I do not deny the risks, but the pursuit of technical efficiency through continuous model refinement, adversarial testing to root out bias, and privacy-preserving techniques like differential privacy provides unparalleled utility. It allows us to manage complexity at a planetary scale, providing a level of personalization and efficiency that simply would not be possible otherwise.
And to summarize the sociological perspective, because these probabilistic inferences dictate real-world opportunities and feed back into human behavior and institutions, they can never be viewed as merely technical conveniences.
Right.
They reshape identities. They categorize people in ways that actively alter social relations. Without stringent regulatory oversight, robust digital literacy, and a fundamental acknowledgement of their psychological impact, these systems threaten to narrow the space of human possibility by permanently locking us into the prejudices of the past.
I think where we absolutely converge today is the recognition that the translation of human traces into data is never entirely neutral. Whether you approach it as an engineer optimizing a decay rate or a sociologist analyzing structural power, the reality is that ethical design must treat users as active participants rather than passive objects to be sorted.
I agree entirely. Looking at the exact same AI pipeline through both an engineering lens of efficiency and a sociological lens of human impact reveals just how high the stakes really are.
There is incredibly rich material here for our listeners to explore further, as they decide for themselves how society should balance technological innovation with the protection of human dignity. The next time you log on and experience that uncanny convenience, ask yourself, is your digital shadow simply following you, or have you started following your shadow?